Hi everybody and welcome to a new video in the Deep Learning for Audio with Python series. This time we're gonna implement a neural network from scratch. Specifically, we're gonna implement a multi-layer perceptron. So let's get started. So the first thing that we want to do is importing numpy. So numpy, if you're not familiar with it, is a scientific library for Python that's used in most libraries. If you don't have numpy installed, you just go to your terminal and pip install it. It's quite straightforward, right? So the thing that we want to build here is a class that's called MLP or Multilayer Perceptron. So here we're going to have all the attributes and methods that we can use to actually represent a multi-layer perceptron. So what's the first thing that we need to do here? Well, it's the constructor. So we want the constructor for the MLP class. And so we are going to have this in it over here. And we want to pass it three different attributes. So one, it's the number of inputs. Then we want to pass it the number of hidden layers. And finally, we want to pass it the number of outputs over here. And so we're going to store these arguments internally in attributes, and this, not surprisingly, are going to be called self.numInputs. So, and this is going to be the num inputs over here. Then we're going to have the number of hidden layers over here, and this is going to be number of hidden. And then we're going to have this num outputs, and we have the number of outputs over here. Well, so this way we just store internally to the instance all of this information about the number of neurons in the input layer, in the hidden layers, and in the output layers. So we can pass in some default values over here because that's going to be like easier, like when we implement an MLP, so we don't need to pass all of this information every time. So we could say that our default number of inputs, so number of neurons in the input layer, is going to be 3, for example. And for the hidden layers is going to be slightly different because we want to pass in a list, and this is going to be a list of integers, and each integer is going to represent the number of neurons in a hidden layer. So basically in this case we have a neuron with 2 hidden layers. So the first hidden layer has 3 neurons and the second hidden layer has 5 neurons. And then finally we have the number of outputs, and so these are the output neurons. Let's say we have 2, for example. Right. So now we want to create an internal representation of the layers. So how do we do that? Well, we want this as a list, and in order to do that, we are gonna cast to a list type this self.number of inputs over here. Then we are gonna concatenate that with the number of hidden layers, and then we're going to concatenate this with the number of output layers. So what this does is basically getting a list where each item in the list represents the number of neurons in a layer, and the layers obviously move from like 0 to the 0 index to the number of layers that we have. Okay, so next, what do we want to do? Well, we need to initiate random weights. So a neural network isn't a neural network if you don't have weights for all the connections between the neurons in subsequent layers. So how do we do that? Well, first of all, let's initiate an internal, like an attribute called weight, and this is going to be an empty list for the time being, and then we want to iterate through all the layers and then create a matrix weight for each pair of layers. So how do we do that? Well, we do a for loop in a range of the length of layers minus 1. So, and then at each step, we are going to build this weight matrix, W, and W is going to be equal to the numpy dot random dot rand, and here we'll pass in layers I, and here we'll have layers I plus 1. Okay, so what have I done here? So I'm basically creating a matrix, which is this W here, using this method from the numpy library, which is random.rand. And what this method does, it creates a random arrays, and the arrays can have different dimensions. So in this case, we have like 2 dimensions. So, and the 2 dimensions are given here by these values. And so here what I'm saying is that I want a 2D array, which is basically a matrix, and the number of rows that I want is the current layer I'm in, and the number of columns that I want is the number of neurons that I have in the subsequent layer. So, and if you remember the weight matrix, this works because on the rows we have all the connections of a neuron from a previous layer with the subsequent layer. So we want for the number of rows to be equal to the number of neurons that we have like in a layer, and for the number of columns we want to have the number of neurons that we have in the subsequent layers, and we can obtain that by using this expression here. Right. And so, and what this random.rand does is obviously it creates this 2D array, so this matrix, and it initiates all the elements of the matrix randomly between 0 and 1. Right. So what else remains to do? Well, we need to store this information. And so how do we do that? Well, super simple. So we get the weights and we do append W. And so here, weights is going to be a list with as many items as the number of weight matrices in the layers, which is the number of layers minus 1. Because if you remember, if we have a network with 3 layers, we're going to have 2 weight matrices, because the weight matrices are always between 2 subsequent layers. So like the first weight matrix is going to be between layer 1 and layer 2, and the second weight matrix is going to be between layer 2 and layer 3. Right, so we have the constructor, and with this constructor we're able to build a representation of a simple multi-layer perceptron. So what do we need to do next? Well, we need to do the actual computation. So we need to do a forward propagation. So we'll create a new method called forward propagate, and this method accepts as an argument the inputs. And what do we do with this forward propagate? So if you remember, what forward propagation does, at each layer, how the signal like travels through, it does like two things. So the neurons first do like a net input, and then they do an activation. So the first part of this is going to be activations is equal to inputs. So the first time, so for the first layer, the activations are basically the inputs. Then we want to do a for loop, and we want to loop through all the weight matrices. And this basically means looping through all the layers in the network. So if we do for w in self dot weights, and then here we should perform a couple of things. So first thing is to do the calculation, so calculate the net inputs for a given layer. And then the second thing that we want to do is to calculate the activations. Right, so how do we do that? Yeah, with numpy it's quite simple, because for the net inputs, if you remember, guys, what we should do is a matrix multiplication between the activations of the previous layer with the weight matrices, with the weight matrix. So how do we do that? It's quite simple. So we do an numpy dot, and this method basically performs a dot product between two vectors, but if we have two matrices, it performs a matrix multiplication. So in this case, we pass in activations, which is a vector, and then we pass in the weights w, right? And this is a matrix. And so basically here, what np dot does, it performs this matrix multiplication between activations and weights, and so we can get the net inputs. Okay, so now we have the net inputs. What's the next phase? Well, we should calculate the activations. So how do we do that? Yeah, it's quite straightforward, because in this case we want an MLP with a sigmoid activation function. So we just need to pass the net inputs to the sigmoid function. So how do we do that? Super simple. So we pass the net inputs to the sigmoid function. Now you may be wondering, well, yeah, but we don't have a underscore sigmoid method. Well, you're right. We need to implement that. And if you remember, we already implemented this in a previous video, and it's quite straightforward, and it'll take us like 2 seconds to do that. Okay, so now what we do is, after we've gone through all of the loop, then we want to return the activations. Right. So let's review this before moving forward. So with forward propagate, we start with the inputs, and this is a vector. And for the first layer, the activations are basically the inputs. And then what we do a forward propagation. So we just like move from one layer to the next one, from left to right. And so we do, for doing that, we do a for loop through all the weight. We iterate through all the weights, and then at each layer we do two things. We calculate the net inputs first, and we do that with a matrix multiplication between the activation and the weights, and then we actually calculate the activations, and we do that by passing the net inputs to the sigmoid activation function. And then finally, after we are at the end of this journey, we just return the activations. Great. So what remains to do here? Well, we should implement this underscore sigmoid function. So here we just want to pass x, and this is super straightforward. We did it already, and the sigmoid function is basically 1 over 1 plus np dot the exponential to the minus x. So here we go. Super simple. Right. So now we have all the elements in place for our MLP class. And so now we can do a full forward propagation, and once we pass in some inputs, we can calculate like the outputs after like the MLP has done its magic. So let's do that. And so in order to do that, let's ensure that we are running the script as like the main. So, and we do that doing if name is equal to main, and then we'll just move on down here. Cool. So what should we do here? So obviously the first thing we want to do is to create an MLP. Obviously we need a neural network first of all. Then we want to create some inputs. Then we want to perform the forward propagation, and finally we'll just like print the results. Print, whoa, what's that mistake there? Print the results. Cool. Okay, so let's do this. So how do we create an MLP? Super simple. So MLP is equal to the MLP class, we call just the MLP constructor. So if we want to change the number of layers that we have and the number of neurons in each layer, we can do that, but we'll just use this default values here. So I'm not going to bother. Okay, so let's create some inputs here. So inputs. So inputs it should be a vector, and the vector should have the same number of items as the number of neurons in the input layer. So we're going to create some random inputs here. And so how do we do that? Again, we know our old friend random.rand from the numpy library. Here, this is a one-dimensional array. So it's a vector basically, and so the dimension of the vector should be MLP dot number of inputs, so the number of neurons in the inputs. Nice, we have the inputs. So we want to get the outputs out, and so to do that, it's super simple because we will just do a forward propagate, and we'll pass in all the inputs. And so by now we should have a vector, an output vector, and now we want to print like what we've done. Okay, so let's do a print network. The network output is, and we'll pass the outputs here, and okay, yeah, let's also pass in let's also like print the input. So the network input is, and here obviously we need to change this to inputs, and down here we have the outputs. So cool. So now everything should be in place. So we built our MLP objects. We created some random inputs. We passed that to the network, which performed a forward propagation. So we have the outputs, and now we've should be able to both print the inputs and the outputs. So what remains to do here? We should just run this, and hopefully, if I've done all correctly, we should be able to see some results. Oh, nice. So the network input is this 3 values over here, and it's 3, and it's correct because we are expecting 3 inputs, because we have 3 neurons in the input layer, and then the output is made up of 2 values here. So there's 2 values here, and it's correct because we are expecting 2 values for the outputs because we have 2 neurons in the output layer. Nice. So basically, you should just like congratulate yourself now, because you've just finished implementing a neural network from scratch. So you now know more than most people like out there about how to actually create a neural network like from scratch. And now you may be wondering, okay, but there's an elephant in the room here, and that's that we haven't trained like our network at all. So how do we do that? Well, this is a huge topic in itself, and it's going to be the focus of my next video, where I'm going to basically explain the theory behind backpropagation and gradient descent, which are like the two approaches, the two techniques which we use to train a network with some training data set. So yeah, next time we're going to do that. So I hope you enjoyed this video. If you did, and if you want to get like more videos, remember to subscribe and hit the notification bell, because that way you're gonna get like all the videos once I upload them. And if you like, again, the video, just like also leave a like, and I guess I'll see you next time. Cheers.